Today we're going to continue talking about unit rates and how we can use unit rates in word problems. Our goals for today are that by the end of the day, students will be able to use unit rates to solve problems, and that you'll be able to use unit rates to calculate the best buy. A quick review on a key point we should already remember. A rate is a word that means it is a ratio that compares two different measurements. For example, this dog here, his name is Tillman. He's the Guinness Book World Record holder for the world's fastest skateboarding dog, and he can skateboard a rate of 100 meters in 20 seconds. We know we can also simplify our rates, like when we take 100 meters by 20 seconds and simplify it to 5 meters in 1 second. As we've talked about previously, a rate with a denominator of 1 has a special name. It is called a unit rate. A unit rate is a comparison of two measurements in which the denominator has a value of 1 unit. So for example, we can calculate unit rates by dividing the first part of our ratio by the second part of our ratio. If Tillman travels 100 meters every 20 seconds, we can divide 100 divided by 20. That gives us 5 meters for every 1 second. 100 divided by 20 is 5. Rates and unit rates are found a lot in real-world problems like distance and time, cooking and mixtures, and prices. We're going to explore all three of these scenarios. A unit rate can be found using these following steps. So we have our example that Homer's speed, we want to write it as a unit rate, and we know that he can run 60 yards in 20 seconds. We know it's a rate question because we're comparing two different units, yards and seconds, or two different measurements. So step 1, we're going to write it as a rate in fraction form. 60 yards over 20 seconds. Step 2 is we're going to divide the first part of the ratio by the second part of the ratio. 60 divided by 20 gives us 2. 20 divided by 20 gives us 1. We're going to keep our units in the same places. So we wind up with a unit rate of 2 yards for every 1 second. The word for every, or the words for every, can be a little bit cumbersome. They're like long things to say. So we're going to try out a new vocab word. This word is per. The word per is used for unit rates like this, and it means for every. So we would say Homer ran 2 yards per second, which means for every 1 second, he runs 2 yards. Let's take a look at our brownie example. Our recipe has 4 cups of flour for every 2 cups of sugar. Step 1, we're going to write our rate in fraction form. Step 2, we're going to divide the first part of the ratio by the second part of the ratio. Both of those get divided by 2. 4 divided by 2, 4 cups of flour divided by 2 is 2 cups of flour. 2 cups of sugar divided by 2 is 1 cup of sugar. So we can say that this unit rate means that there are 2 cups of flour per cup of sugar. Even though the cups sound like the same, these are 2 different measurements and 2 different types because we're talking about cups of flour and cups of sugar. Finally, we have our grocery store example, which we're going to be solving in a proportion. The giant bag of popcorn costs $6 for every 24 ounces of popcorn, and the mega bag costs $10.24 for 32 ounces. We're going to calculate the unit rate of the giant bag. You can see I already have the unit rate of the mega bag there. I used it in a proportion. That's how I solved it. Which is what I did was I said, how do I get from 32 ounces to 1 ounce? I divided by 32. So I'm going to do the same thing, starting on the left, going to the right. Divide $10.24 by 32. That actually gave me 32 cents. That's how I got the unit rate for the mega bag. So I would fill in the same information for the giant bag. The information they already gave me was the rate of $6 for 24 ounces. I know that I want a unit rate, which means 1 ounce, and I want to solve for how much that costs. So I would look from left to right or up and down. I can see very easily that to get from 24 to 1, I would divide by 24. Oops, went too fast. Gotta go back. So I can see that I would have 24 divided by 24 equals 1. And then I would have $6 divided by 24 equals, we have to do that math. Our final key point for today is that we can use unit rates to make comparisons and solve real-world problems. Unit rates normally appear most often when you're buying things and you want to get the best deal. You want the most for the least amount of money. So, for example, I went to the store with my sister and I wanted to buy the mega bag of popcorn and she wanted to buy the giant one. We tried to figure out which one is the better deal. So, we know from our last example that we had a unit cost or a unit rate of 32 cents per ounce for the mega bag. When we did our $6 divided by 24, we should have wound up with 25 cents per ounce, which means that we could say, if this is 25 cents per ounce, then I can use that information to compare. Well, for every 1 ounce of the giant bag, I pay 25 cents. For every 1 ounce of the mega bag, I pay 32 cents. So per ounce, it's actually cheaper to get the giant bag because it is 7 cents or $0.07 less than 1 ounce of the mega bag. So that's how I could use a unit rate to calculate a best buy situation. Let's do a quick check. We want to know the unit rate if you saw this word problem. You pay $5 for 25 pencils. What is the cost per pencil? Remember, we talked about steps earlier. We're going to take the first thing in our ratio, the $5, and we're going to divide it by the second thing in our ratio, the 25 pencils. So what I would do here is I would say $5. I'm actually going to say $5 and 0 cents because I have a feeling that each pencil is less than $1, divided by 25. Now remember, I can set this up as long division. My $5 and 0 cents goes inside. My 25 goes outside, and when I have a decimal in my division house, I'm immediately going to raise it to the roof. So there's my decimal. 25 goes into 5 0 times. It does go into 50 2 times. 50 minus 50 is 0. Bring down my next 0. 25 goes into 0 0 times. I know that I'm done with my division problem when I have a remainder of 0. And I have a number in my quotient above every digit in my dividend. So I can see that I have a 0 above my 5. I have a 2 above my 0. I have a 0 above my 0. I don't have any more digits in my $5, and I have the same number of digits or the same number of place values in my quotient. Remember, my quotient is talking about money. Every 1 pencil, the cost per pencil is 20 cents. You can also figure that out from a table. If you see that I can type 100 words in 4 minutes or 125 words in 5 minutes, you can calculate, well, how many words did I type in 1 minute? You can use either one of these. I'm going to start with this one right here. 100 divided by 4 is 25. That means that I can type 25 words for every 1 minute. If you wanted to check, you could go do 125 divided by 5. That is also 25. 25 words for every 1 minute. And that's how we do unit rate problems.